Hi ladies and gentlemen, this is Mr. Green. This is another in my series on Algebra 2 lessons that I hope you are watching and making good use of. So let's see here. Where are we supposed to be right at the moment? Well, I'm going to be covering something from Unit 7. So you should be finishing everything that is in Unit 6 right at the moment. And so I'm hoping that you're getting that completed. So you should be finishing most of the stuff that you see in Unit 6. Okay, that includes the unit tests, Part 1 and the Part 2. I do allow you to make some quiz corrections. I do not have it as a item in the course or anywhere. So if you just need to make quiz corrections or corrections to the test or things like that, if you let me know, if you can't get into see where the correct answers are, and then just put it in a Word document, send it to me via Kmail, we'll get it taken care of for you. Due dates, we're still closing things after 28 days. So that means if you're working on something and you've got a 0 on it, you need to let me know about it because after 28 days it gets locked up. You're not going to be able to get it taken care of after that. Okay? So what are we looking at today? We're talking about simplifying radical expressions. We're going to write some radical expressions in simplified radical form. Now we're only going to be looking at square roots. We're not going to do anything more complicated than that. But we're going to be looking at simplified radical form. And we're going to look at adding, subtracting, multiplying, and dividing radical expressions. Radical meaning square roots. Okay? So that's what we're going to be looking at today. First of all, when we're simplifying something that's in radical form, as long as a and b are not 0, the square root of a times b is equal to the square root of a times the square root of b. This is called the property of products, okay, when you're multiplying products of radicals. And the quotient property is very similar. You can't have a and b equal to a and b both have to be greater than 0. But if I take the square root of a divided by b, that's equal to the square root of a divided by the square root of b. So let's look at just a couple of simple things to begin with. How do I find the simplified radical form of this one, of square root of 80? Well, the first thing I'm going to do is I'm going to factor 80. Well, I know that 80 is 4 times 20, right? Yeah, 4 times 20. And 20 factors into 4 times 5. Well, those are I know I can factor the 4's down to 2's, but if you look at this, I have two 4's sitting right there. That means I've got a 4 times a 4 times a 5. So I've got in this one the square root of 4 times 5. Well, we know the square root means something times itself, right? Well, I've got a 4 and a 4. That means I could pull a 4 outside of the radical sign, and it's 4 square roots of 5. That happens to be the simplest radical form. Okay? Over here on this one, I'm going to start off by just saying the square root of 2 divided by the square root of 9. Hopefully everyone knows the square root of 9 is 3, so what I wind up with is the square root of 2 divided by 3. That would be my simplest radical form. Moving forward, when I'm looking at something like this where I've got the product of two numbers like this, one technique is to go ahead and multiply these together. Okay? And I don't have my calculator running on my computer right at the moment, so I'm just going to multiply it on the one in my hand. 12 times 27 is equal to 324. So I've got the square root of 324. And I now need to look at 324 and say, well, that's going to be, let's see here, 3, 5, 6, 7, 8, 9. It's divisible by 3. And all I did there was add up the digits real quickly. 3 and 2 are 5, and 4 is 9. 9 is divisible by 3, so the number is divisible by 3. So what do I get when I divide it by 3? I get 108. Well, I recognize 108. That's 12 times 9, right? Well, 12 also factors into 3 times 4. I want you to notice I've got two 3's, I've got a 4, and I've got a 9. I'm going to actually write that as square root of 3 times 3 times 4 times 9. Well, 3 times 3 would come out, and I would have a 3 on the outside, times square root of 4 would come out, 2. Square root of 9 comes out, 3. And there's nothing left under the radical, but that would be my answer. Okay? And that would be, let's see here, 3 times 2 is 6 times 3 is 18. Now, just using a calculator, if you take the square root of 324, you get 18. Okay? So it works either way you do this, whether you multiply it together to begin with or if you factored it to begin with. I'll show you that one over here. 98 factors into 2 times 49, and 32 factors into 2 times 16. So when I'm multiplying these together, I've got the square root of 2 times 49 times 2 times 16. Well, that would be, since there's two 2's here, a 2 will come out, a 7 will come out, and a 4 will come out. And we're multiplying those together. 2 times 7 is 14. 14 times 4 is 56. And that would be my answer. Okay? So let's look at this one. A little bit more complicated. Okay? We've got a 7 here. I don't think 7 is going to factor, but 6, well, that's an even number. So if I take that, it's going to come out as 3. We're going to have a square root of 7 in here still. Square root of 6 is going to be x cubed. Square root of y cubed is going to be y square root of y. Why did I get that? Because that was y squared and times y, right? Well, y squared comes out as a y, and the y remains underneath there. So you can see if it's an odd number, what am I going to do? I'm going to leave 1 underneath it and pull out a half of what the number was. Okay? And I've got times 4. Square root of 32 is 4 times 9, 4 times 8. Yep, 4 times 8. Square root of 4, square root of 8. Whoop, that's square root of 4 times square root of 2. You see how I'm just making square roots of each one of them. Square root of x to the 4th, square root of y to the 4th, and square root of y. Do you see how on this side over here on the right, I just kind of broke it down into all of its different parts. So what am I going to have? 3 square root of 7, x cubed, y, square root of y, 4, 2, 2, square root of 2, x squared, y squared, square root of y. Now I've got 2 square roots of y here, so that's going to be 1y. I've also got a y squared, so that'll be y to the 3rd, and another y there, that'd be y to the 4th. Do you see where I got that? There's 1, there's a half, there's 2, that's 1.5 plus 2 is 3.5, and then there's another half, that's 4. Okay? Count my x's. I've got 3, 4, 5. So I've got x to the 5th. Okay? I've got 3 times 4, that's 12, times 2 is 24, times 2 is 48. Square root of 14. That's 7 times 2. So it'd be 48 square roots of 14, x to the 5th, y to the 4th. That would be my final answer. You notice how I put the number first, then the radical, a number inside of the square root sign, and then my variables behind it. And I always have to end it with this thing so that you can tell the end of the square roots. That would be the way that I would put this together, in the order that I would put them. Okay, so let's see here. What do we got in this case? We've got square root of 3, square root of x squared, square root of y squared, square root of y, times 2 times square root of 72. That's 9 times 8. Square root of 8. Well, that's 4 times 2. Square root of 4. Square root of 2. You can see I'm doing these as we go. Square root of x squared. Square root of x. Okay? So now I'm going to write down anything that I could get the square root of. Square root of 3, x, y, square root of y, 2, 3, 2 times 3 times 2, square root of 2, x, and then a square root of x. Okay? So now I'm going to multiply the numbers. 2 times 3 is 6 times 2 is 12. I'm going to multiply the numbers that are under a radical. Square root of 3, square root of 2, that's square root of 6. I've got x squared, y, and then square root of xy. X times y. That's what I would list as my simplest form. Okay? This other one over here, kind of getting a little lost in the time here, so I want to make certain I'm going to do it fairly quickly. I've got the square root of 7, the square root of p squared, square root of p, square root of q to the 6th, times 3 times 2 times 100. Square root of 2 times the square root of 100. Why did I do that? Because 100 is a perfect square. Square root of p to the 6th, square root of p, square root of q. Okay? So writing them down, square root of 7, p, square root of p, q to the 3rd, 3, square root of 2, 10, square p to the 3rd, square root of p and q. Okay? Well, I've got two p's that are underneath it, so that's going to come out as 1p. I can see that one already. Multiplying my numbers together, I got 3 and 10. That's 30. I've got the square root of 14. I've got 1p, and then I've got 1.5, 2 p's, and a p to the 3rd, that's p to the 5th. I've got a q to the 3rd, and I've got the square root of q. That p got taken care of over here. Okay? That would be my final answer. You can see it takes a little while, but once you get used to doing it, break them down into the individual parts, take the square root of every one part of it, and it works just fine. How do I do something like this? Well, this is nothing more than the FOIL method. I'm going to use the first, inner, outer, last. Okay? And it shouldn't be a problem for me to multiply these together. So what's the square root of 2 times the square root of 2? 2. What's the square root of 2 times the square root of 5? Well, that's plus the square root of 10. Okay? Plus, well, the square root of 3 times the square root of 2 is the square root of 6, so that'd be 3 square roots of 6. And which one am I missing? Oh, square root of 3 times the square root of 5 would be plus 3 square roots of 15. That would be simplest form. Do you see how I did that? By using the FOIL method. This was the square root of 2 times the square root of 2. This one was plus square root of 2 times the square root of, or 3 square roots of 3. And the next one would be plus square root of 2 times, oops, that would be this one here. Square root of 2 times the square root of 5. That'd be this one there. Okay? And then this last one would be the square root of 5 times 3 times the square root of 3. Okay. Now, one of the things that comes up when we're looking at this is how do we rationalize a denominator? What do we mean? Well, having a square root in a denominator in the bottom half down here is not what we would call simplest form. So what do? Well, we use a simple trick. We multiply times what's in the denominator. This is called rationalizing the denominator. Square root of 13 times square root of 13 is simply 13. And then I have 2 square roots of 13 in the numerator. Okay? Same sort of thing here. I'm going to multiply times the square root of n to the 7th power divided by square root of n to the 7th power. Okay? That's going to wind up being n squared square root of n to the 6th square root of n divided by n to the 7th. Well, this comes out as n to the 3rd. And what do we got? We've got n to the 5th square root of n divided by n to the 7th. Well, you know what? Since they're all n's at this point, we could actually write that, and I'm going to move over here. We've got n to the 5th, n to the 1/2, n to the negative 7th. We're multiplying these together. You can just add the fractions together, and what you'll get is n to the 1 1/2, or 3 over 2. How did I get that? Well, 5 and negative 7 is a negative 2, and negative 2 plus 1/2 would give me 3.5. And that would be what I would list as this one in simplest terms. Okay? Okay, let's look at that one again. One of the things we can look at by doing this is we use what's called the conjugate. If you see right here, see how I got a plus sign in here? I got an a plus the square root of b. The plus sign, its conjugate form is called a minus the square root of b. That's what I would multiply this one down here by. 3 times this minus square root of 2. In case you don't recognize it, plus, minus, I'm going to wind up with a difference of squares. My difference of squares in this situation is going to be, got to multiply by 1, so I got to multiplying by that. In the denominator, I get a difference of squares. That's going to be 9 minus 2, difference of squares. Well, it's not, 2 is not a square, but in this case, square root of 2, square root of 2, that's going to wind up being 2. And on the top, what am I going to wind up with? 15 minus 5 square roots of 2. Well, 9 minus 2 is 7, so what am I going to wind up with total? 15 minus 5 square roots of 2 divided by 7. Cool? That's one of the ways we can do that. Let me show you that one again. Here, what I'm going to multiply this one by is x minus the square root of 7y. I'm going to multiply that times the numerator and the denominator. X minus the square root of 7y. Okay? What I'll wind up with in the denominator is x squared minus 7y. What I'll wind up in the numerator is 2x minus 2 square roots of 7y. That's the way you rationalize that. That's how you would get that in simplest form. Okay? Now, what do we do about adding and subtracting radical expressions? Well, as long as they're the same numbers underneath the radical, you can treat them like they are the distributive property. So I would rewrite this one as 8 plus 1 times the square root of 6 plus the square root of 5. Well, 8 plus 1 is 9, so I would get 9 square roots of 6 plus the square root of 5. Hope you can see that what I'm doing there. What I'm going to try it is on this one. Well, 12 or 48 breaks down into 4 times 12. 4 is a perfect square here, so it's going to come out as a 2. And I'm going to have 5 square roots of 12 minus 6 square roots of 12. I'm going to pull the square root of 12 out and have 5 minus 6. Okay? And this is going to break down into 3 times 4. So what I'll wind up with is 2 times the square root of 3 times negative 1, or negative 2 square roots of 3. That's what I would get in my final answer. Okay? Let's try this one. Okay. I'm going to first of all break each one of these terms down. Okay? 48 breaks down into, let's see here, 4 times 12, or 4 times 4 times 3. Yep, so that's going to be 4t squared square root of 3t minus t squared times the square root of 3t minus square root of 3t. Okay, factoring out a square root of 3t, each one of those terms has it in it, I would have 4t squared minus a t squared minus 1. Well, that's going to give me 3t squared minus 1 parentheses times the square root of 3t. That would be my simplest form. Okay? Okay. I do appreciate you guys sending me the fact that you're in Algebra 2 every time. It does help me keep things straight. A lot of courses I'm teaching. I will look forward to seeing you next time.